reading for CNC programmer. So since CNC programmer are involved in writing program for the machine, so the machine can go through the product, move around specific coordinates, and do some specific tasks. So the engineering drawings is very important for CNC programmers. So without the engineering drawings, you cannot write the correct CNC program for the machine to conduct the task, either for milling, turning, any type of task for the CNC machines. So in this, actually, the blueprint here is, I mean, it's a book. It's a book of more than 16 chapters. So in this chapter, we try just to select some specific part of blueprint reading. So we can go through, we can practice some exercise to learn how to know or how to read the readings, the type of the reading. I mean the drawings and the type of the drawings, type of lines. Dimensions, tolerance, and so on. Okay, so we are going through some important part of blueprint readings for CNC programmers. So these are the course outcome or the expected outcome from this chapter, and what you are expected to learn by the end of this chapter. And here is updated for the references that we are going to use in this chapter. So we are going through the, I mean, in the beginning we will talk about why we need blueprint and how it's important for CNC machines. Then we are going to learn how to read some or how to extract views of the drawings, and how to read dimensions, how to know tolerance, and so on. These are the content for chapter 3, and actually in chapter 3 there is no a lot of text, mostly are drawings and with some specific dimensions and standard parameters. People who work in the industry or work in manufacturing industry, especially in the factories and so on, they need to have some common language. So this common language actually they are going to use from the first of the project until they have the finished product. Okay, we said previously when we talk about the CNC component, we see how the CNC programmer have an idea about the product, then convert this idea into a program. This program will be sent to the program reader in the MCU. Then the MCU will send it to the machine, and the machine will apply it on the language to read, or I mean to communicate without a lot of explanation. It's not language of talk. It's the language of blueprint. Okay, so this language of blueprint, the designer will prepare the drawings for the product with the specific or the standard dimensions. They will highlight the dimensions, they will highlight the views and so on, and they will provide all the information about this product inside the engineering drawing. This drawing will be sent, I mean, from the designer will be sent to some technicians or some operator on the machine to conduct the task and to produce this product. So the such information which will be included, like dimension, tolerance, material, the type of the material for this product, and how the assembly direction of this product, and I mean by defining the direction of the machine movement and so on. So all this will be explained in the drawings or in the engineering drawings, and these drawings actually consist from lines, numbers, symbols, and so on. So blueprint here can be in different ways. So some they provide blueprint as a sketch by hand. So they sketch some drawings by hand, they provide some dimension and so on. Some they use drawing by using software. So there is a specific, and this is the most common way to produce the product by using the software as powerful tools, providing the, I mean, for drawing the products. Okay, so there is drawing here. This is the most common way to do the engineering drawings, which is using the softwares. There are a lot of software like Autodesk Fusion or SolidWorks and many other software that they use to provide either, to provide 2D drawings or 3D drawings and so on. Okay. Some they use sketch, some they use also pictures. Okay, so sometimes the picture also can help to understand the nature of the product and the dimension of product and so on. So importance of engineering drawing here, it shows the size of the product. So what is the width, for example, what is the height, what is the depth, the shape of the product, is it rectangular, it is circle or cylindrical or spherical and so on. Also the feature of the part to be machined, or you want to make it a hole for bolt or for drill and so on. It's just like you add some part, there is some extra parts, combined from 2 parts, 3 parts and so on. What are the parts that you want to produce? So the engineering drawings will provide the engineer with all the required information to perform machining using CNC machine. Usually it's produced in standard format. So they have some standard format for engineering drawings. So whatever is the company who makes these drawings must be understood by all engineer who work in this field, or technician who works in the same in the field of manufacturing or producing products. Machine carries require ability for interpolation. Then, so I usually after they do the drawings, they have some information which is directly related to the dimensions, the shape, and so on. And there is some information which is related to the material itself, that they want to produce this product from which material, from which combination of material and so on. All this information will be provided in the drawings of our engineering drawings. Usually there are different type of engineering drawing, or engineering drawings is used by electrical engineer, it's used by electronic engineer, by manufacturing engineer, by mechanical engineer. All they also construction engineer, architecture engineer, or they have their own they have their own standard for perform these drawings. So if the architecture engineer make a drawings, another architecture or civil engineer should understand what he means by this one. The company who will accomplish this building, for example, should understand this drawing and what are the the lines, the symbols and letters inside these drawings. The same is with the manufacturing of products. These are the type of alphabet, of lines. The type of lines that is used with drawings. We have different lines or different type of lines that used for in the engineering drawings. These lines can be a continuous line, can be dash line, hidden line, center line. Some lines are thick, some lines are thin, some continuous, some have dash and so on. Some also they have some break lines or in the engineering drawings. And each type of this line is specified to be highlight some part of the engineering drawing. So as you can see here in this example for line type here, we have object line, for example, which draw the of the product or the product that will go through the manufacturing. There is a small dash. So this is highlight what is the center of this product around the z-axis, for example, or around the x-axis. So that means this line is go through the center of the product. We have also dimension lines, which indicate the dimension between this border to this border. What is the dimension? So this we call it dimension lines. We have a leader line, which is connect. I mean, which indicate the, for example, if I want to highlight the border of this product, so we have some type of line to highlight this one. If we want to represent some hidden lines in the form of dash, so this is to represent the hidden part which cannot see, for example, from the front view or from the top view or from the side view of the product. So different lines are used for different representation of the product. All these type of line are standard, and usually when they want to use dimension line, they have to use like this line with two arrow here at the end to show the dimension. If they want to use center line, they have to use line with a small dash here, so to show the center line of the. If they want to use to represent some phantom, I mean some part of the product which need to be represented by phantom line, so they have to use the phantom line. Hidden line also they have to use hidden line also. So this type of lines actually is like standard lines, and it will be repeated in all type of engineering drawings. Manufacturing material as well, represented by some dash or lines or some figure here. So when they add such representation for so for example, if you see like this one, so I understand this is from cast iron. This product will made from cast iron, for example. This product is made from electric insulation material. This from rubber, this from steel, this one from gold, this one from bronze, silver, and so on. So I mean, each material is represented by also lines, but here the lines you can see what is the difference between all these lines. So this is like standard representation for the manufacturing material that they use to produce the products. And it will be shown or represented or mentioned in the electrical, I mean, in the engineering drawings. Component of engineering drawings here. If you have any engineering drawings, if you have seen any engineering drawings before, either for electrical drawings, for example, for the house, if there is someone who make the installation for house wiring, for example, he need to follow drawings. If you have a machine, you bought a machine, for example, this machine, it has a catalog or user manual. So inside the user manual, there is a drawing to explain what is the part of these machines. All type of, if you want to build new house, also the engineer will provide you with some drawings to see. So what are the common or the most important part of the drawings? The first is the title block. So there is a block, they call it the title block inside the drawing. Other is the revision block. So it shows the history of change for the drawing. For example, this drawing version 1, version 2, version 3, when they change this version 1, when they make this version 2, and so on, if they have some modification or alteration about on the drawings. They have some information about the scale. So how we can reflect these drawings in the real environment or in the practical product. So what is the scale? Is it 1:1, 1:2, 2:1, and so on? It depends on what is the scale of this drawing. The bill of materials, or what are the materials that used for producing these drawings. So as you can see here, this is the definition for all these main components, which is the title block, revision block, note block, and part list. You can go through if you have such drawing here. So here, for example, you have the main title block. So usually the main title block is placed here. On the left here, you have some about the materials, about the company that they develop. Also, you have here secondary title block for to highlight the revision part and so on. In this area here in the middle, they usually place the drawing location or either the view for the top view, side view, front view, and so on. So this is the commons, and here you can see some numbers on the top, some number on the bottom. Here it's like column and row. So in order to follow the drawing here, they can indicate like this. They use this number for indexing, especially for example for electric circuit or electronic circuit. If you want to refer to any component, you need to indicate where is the place for this component. Is it on the 4, for example, on the x-axis, on the C, on the y-axis, on the D, on the y-axis, and so on. So it's like coordinates to define the place of this, of this component. In addition to the scale, all information about the scale here will be found. The information about the material will be found here on the top left. You can see here. So the notebook here is located on the left of the title block. The title block here placed on the lower right hand corner. So where is the lower right hand corner? This is the lower right hand corner. So this is the title block. Then from the title block here, we have the revision block, which is placed on the upper right hand corner. So you can see here, this is the upper right hand corner. So this is the title block. Then you have the note block. It's located on the left of the title block. So that means you have the title block. On the left of this title block, you are going to find notes block. This notes block will showing the tolerance, the material, the surface finish, and application, and so on. So all this will be placed on the left of the title block. So this is the title block here. All this we call it title block. On the left here, this is the, you can see here, this is material. This is some information about the material, about the tolerance, about the finishing of the product, and so on. All will be located on this place. So here you can see the specific, also the name of the company, for example, the part name, the scale, the units, author, date, any other necessary information. All these will be placed either in the main title block or in the secondary or the revision block. So later we will see a lot of such drawings with some details, and it's more clear to see also the projection. Is it third projection or first projection, and so on. This is more details drawings here. So the title block here contains the information including the part name, tolerance, and scale. So you can see here the part name and tolerance and scale of this. All information will be placed on this one. You can see the name of the company. You can see the name, the material. For example, here is aluminum. All this, the size, the scale, all information will be placed on these blocks here, in addition to the main drawings. So the main drawings here will be placed in this area, either the top view or the sectional view or the side view. All will be placed in this area. So here also any information about the updates with the dates will be indicated here, and who approved these updates, and so on. So you can see here, this is part C, which is the place or list the raw materials. The part A, which is place the information about tolerance and other scale, and so on. And the part B here, which place the information about the change or revision made for this drawing. So this is some of the drawing codes that need to be defined in the engineering drawings, like the dimensioning, which is the dimension of the product, what is the height, what is the depth, what is the length, and so on. Tolerance, what is the error, or between the acceptable variation in the dimension. For example, I want this product to be 4, but I can accept if it is 4.05. I can accept if it's 3.95. So this we call it the tolerance, or the change or variation in the desired dimensions. Thread forms and dimensioning here. If there is some threads related to the lead screw that we learned before about the lead screw threads, and so on. Surface finish and symbol and notes related to the surface finish. We are going to go through all these one by one. and we are going to learn how to find the dimensions, how to find the or to extract the view from drawings and so on. So orthographic projection here, it's related to how we can see the product, because usually the product is not a two-dimension product, it is a three-dimension product. So if you have a cubic or spherical or cylindrical product, so all this, it has more than two dimensions. But in order to make this a three-dimension into the two-dimension drawings, in order to make the design and so on, we need to make projection for this product. So we need to define different views for the product. The most common views that we need to know about any product is the front view, the top view, and the right side view. Okay, so the front view, that means you looked at the product from the front side. So this we call it the front view. The top view, you put the product, for example, on the table and you stand, you look at the product on the table from the top. So it will be top view. Right side view, this is you look at the product from one side, which is the right side. So these are some products, but sometimes it's also there is some hidden part of the product. It cannot be appear in these three type of views. For that, we need to have some other external or additional views. These additional views like cross-sectional view, or you are going to take some part of this product to get the view what it will be represent, to show the hidden part or the part which is not appear during these three type of views. But this is the most common views that you need to find or you are going to see on the engineering drawings. So usually when you want to see how this view can be extracted from the product, you imagine that you put this product inside the cube or glass, inside a glass box here. So inside the glass box, if you want to see the front view, for example, the front view will be reflected or projected on this front side of the glass cube. The right side of the product will be reflected or projected on the right side. The top side of the product will be reflected or projected on the top side of the glass box here. So these are the three main views that you need to be projected. Projected to see or to extract the real product. So usually the product, for example, here is it's not it's it's a cube, for example, or it's not two-dimension, it is a three-dimension. It has a depth here. So this is the depth for this product. This is, for example, the width. This is the length. The length and the width. And this is the depth or the height for the product. So it consists from more than two dimensions. So in order to represent it into two dimension, you need to project this view in a three view form. So for example, for the front view here of the drawing, it will be projected on the front surface of the, see how you extract, this is the product, and this is how this product will be projected on the glass from the front side. So usually if you have, this is point A, this is point B, this is point D, this is point C, it will project it into these 4 points also. And when you represent it in the two dimension here, it will be like this one. This is A, so the top point is A, then you have here the down is B, then you have here D and C, same D and C. So this is the front view of this product, for example. For the second here, we have to represent for the top view. So you are going to project the top of this product on the top glass, on the top side of this glass. So you are going to project the point D into this point, the point F into this point A into that point G into that point. So when you draw here, this will be G, A, F, D. G, A, F, D. It's the same, so this will be the top view of the product. Same for the side view or the right side here. Usually they consider the right side is the most common one for the right side. And when they make, I mean, when they see from the look from the front, that means the back will be almost the same. If there is some differences, it can be represented by using hidden lines. Okay, so here for the right side also you are going to the blue rectangular here will be projected on the right side of the glass box. So when you represent it, it's the same. This is F, this is E, this is D, this is C. So this is D, C, F, E. So this is the right side view of this project. Try to focus on how they locate the point. So the point F here is located on that side. The point D is located. It's like you take the rectangular and put it on the flat surface. There is also the isometric view, and this isometric view which provide you with 3 dimensions of the product. So you can see the top of the product, you can see also the front, and you can see the right side. So the isometric view, it will represent or it show you the 3 dimension or the 3 dimensions of the product. So from the angle of view of this product, you can see the 3 views, either the top, the front, or the right side of this product. Usually this provide more information about the product if there is some, I mean, because in the top view, you are going to see only some rectangular here. I mean, like 3 rectangular, for example, like this one. So because this will be represented by 1, this is by 2, this is by 3, for example. But when you have this isometric, so you are going to understand that means this there is a height here, there is another height here, there is another height here. It's not just one height or one depth for the product. So how to read these drawings actually? How we can read the drawings? I mean, as a CNC programmer, for example, you want to write a program for the machine. You have the drawings, but how to convert this drawing into a real program? The first, you need to know what are, when I ask the machine, for example, to go to the right, go to the left, go up, go down, ask the table, I mean, make the table move left, move right, and so on. So all these based on the coordinates. So when based on the coordinates, that means will be based on also the dimensions. So if I have the product, for example, is placed on the XY plane and this area here. So I need to define all dimension of this product. If I know the dimension of this, I mean, this line and the dimension of this line, by using the coordinate system, either the absolute or the incremental coordinate, I know how the machine will move on the XY plane or the XZ plane or the ZY plane and so on. It depends on which plane is working or what is the type of machine. How many axes do we have? 2 axes or 3 axes? Okay. So how we are going to see this length or to measure this length or this depth and height and so on? All this depends on the how you are going to read the drawings that you have. Okay. So each dimension here will appear only once time. If you have a drawing here, so that means if I said this is the height, the length, for example, is 5 millimeter. So I am not going to see other on the other side it is 5 millimeter because it's by default it's only one. I know, for example, if this is square, all I mean will be 5. If it's rectangular, for example, it will be this line will be equal to that line and so on. So no need to repeat the dimension from different views. So you will be represented by 1 times. Then need to proficient read, I mean, for also drafter may place dimension on different view than expected. So for example, you expect you are going to see this dimension from the front view, but the drawer or the one who make this sketch or who makes this drawing, he make it on the front view. So on the same, it is the same. It doesn't matter in which view that you have the dimension, but the dimension is there. So your task will be how to know what is the dimension for this line. Is it 2 millimeter? Is it 10 millimeter? Whatever, is it from front view or from side view? But I'm talking about the same dimension or the same line that I want to measure or to know its dimensions. So in this case, you need some proficiency in reading the multi-view drawings. So since you have, we said every drawing will be represented by at least 3 views. So top views, top view, front view, and right side view. So you need, from these 3 views, you can know some of these dimensions. Or I mean, you must know all of these dimensions, not some. You must know all of these dimensions. We are going to see some exercise later on about this, how to find the dimension for from different views. Also, we need sometimes you need to do some calculation. Why you need to do some calculation? Because some dimension are given. I mean, like it's not direct dimension. So, for example, I have, because I do not have only one line. For example, I have this line, and maybe other lines is there. So if I give you this dimension, which is 5, 10, for example, and then I give you this is 5. So how to know what is the dimension of this part? It will be like 10 minus 5, for example. Or this 4, it will be 10 minus 4, it will be 6, and so on. So sometimes you need to do some calculation to know the dimension of the engineering drawings. So formal drawings here, you need, usually if you have drawings and you want to read these drawings to understand what's included and to convert the information in the drawing into a program that will be fed to the CNC machine, you need to have detailed multi-view representation of the finished part. So you have the part or the finished part there, which consists from, I mean, like isometric view, which show you the part. Then you have extracted views, which is the front view, the side view, the right side view. Then also you have this title block. In the title block, you will have many information about the product. Like as we said before, the scale, how to convert this drawing into a real product. That means you need to have the scale. Scale, is it 1:1, 1:2, 2:1, and so on. Also, what is the material that we use to produce this product? What is the size of this product? What is the capacity of this product, and so on. So I mean volume and so on. So all this information can be extracted from the formal drawings, from the reading of formal drawings. So this is the example for or sample for formal drawing, which provide you with the, I mean, this is the like isometric view of the product. Then you have here the front view, the side view, and the top view of the product. So the 3 type of views will be for the product here, for the 3 sides. I mean, for the from the top, from the front, I mean, and from the right side. So in addition to the information which is represented in this area, as you can see here, you have the type of the material here, steel. For example, here steel ANSI, the standard 1050, steel NSI 1040, for example. The angles, what is the angle here, what is the tolerance values for the angle, for the line, for the rate, and so on. What is the type of the object projection here? Is it first angle projection or third angle projection, and so on? What is the I mean the revision date, and so on. All these information are available in one drawing. So as a drawing reader here, you need to extract all this information and convert it into a real, I mean, into a values that will help to write a program. For example, here you can come to this view here, you can see there is 85, there is 50, there is 15, 35, all these dimensions. So this dimension actually will be, there is, for example, a hole here or a circle, there is a circle there, there is a circle there. This all represent these circles on the main shapes, for example, yeah, for the right side view. This is for the front view here, you have an angle because you do not have a straight line here, you have angle here. So how to represent this angle, what is the value of this angle, and so on, what's the difference or the distance or the length between the first angle end and the second angle end, and so on. All this information can be represented by this, by front view, for example. For the top view, This will be, I mean, what is the, you have here 100. This is one of the dimensions which represent, I mean, the length of this line, for example, which is 100. And from the other view, you can find the length of this line, the length of this extra line. So this information will be extracted from the drawings. Later on, you are going to see how you can use this information into or to write the program, or to direct or to guide the machine spindle or machine head to move up on top of the product, to create this product and to come out with a real product at the end of the process. So this is how to extract the view here. For example, if you have, this is isometric view. Isometric view represents the view we said from three direction or three dimensions. You can see the top of the product, you can see the front, you can see, I mean, the front, and you can see the right side. So how to convert this view or isometric view into the three view that we know: top view, base view, or front view, and right view. The base view here means the main the view of, or the front view, and the right view is the right view from this side. So how to convert this one? This is the first step. If you have isometric view, you need to have top view, front view, and right view of this product. Then all this view will be placed inside the I mean, the drawings. So this is the task of the one who will do this sketch or make these engineering drawings. The task of the CNC programmer will be just how to read the dimensions, how to read the tolerance, how to read these values from the given drawings, and how to convert this one into G code or A code for the machine. This is about the detailed feature that we can get from the product, either for the top view or for the front or right side view. So this is, if this one is the isometric representation of the product, so how we can see different orthographic views for this product, for example. So how to identify the center lines, how to identify the center mark, and so on. So as you can see here, the product is not, there is like a curve in this area. It's not like straight line. Okay, so when you represent the side view here, this will be considered. This part and this part will be considered because they are not 90 degree. It is not like this one. So there is some curve here. So this curve, when they make to draw, when they draw this one, they have to consider what is the radius, or what is the diameter of this curve. So this is the front view. The front view, that means they are going to see the product from this side. So this a bar until here, which is the curve part. Then you have here another part until the down, and then you have this part. Then you have, this is the curve part. Then you have down, and this one. So this is the front view, for example, for the figure. I mean, for the isometric view. For the top view, for example, they are going to look from this side, so they are going to see this line, which is represented here with the center line. The center line here represents the center for this. Since you have a circle here, so there is a center line for this circle. Then you have also, this is the cut edge of this one. Then the rest of the product. So this is how to extract the detailed features of views from the isometric view. Usually all these four figures will be included in the engineering drawings. That means you have isometric view, you have top view, front view, and also right side view. In order to, there is two way actually to represent for projection for the engineering drawings. The first, they call it first angle projection or third angle projection. It's like two different system of projection for the views. So from which angle you are going to look at the product. So this third angle projection is used in US and Canada, for example, and the rest is used, or the first angle projection is used in all other country over the world. This is like a type of standard for projection. So as you can see here, if you have two perpendicular plane, so this is one plane here, perpendicular with the other plane here with the angle of 90, for example, there is this is perpendicular to each other. So as you can see here, we have four angles. We have angle number one, which is between the vertical and the first line. If you say this is one, or this is A, this is B, this is C, this is D, for example. So the angle between the plane B and A, we call it angle number one, and this is the angle here. The angle between B and C is angle number two. The angle between C and D is angle number three. The angle between D and A is angle number four. So in order to represent the front view, when we say front from which side? Because sometimes the product you can take the product, put it on different side, on different. For example, your mobile front is the front where is the screen, the back is where the camera. You have rear camera, you have front camera, for example. So if I want to see which one is my front view, which one is the other, I mean the top view, which one is the right side view, which one is the will be the left side view. So this is depends on what angle that I'm going to see, the viewer angle. So this is the viewer here. If he looks from this side, so for example, this will be like first angle view because he focused on the first angle side of this view. So the view is come from this side, from this way. It's all focused on the first angle projection. But if you go to look from the other side here, so you are going to call it the third angle projection because your the way or the angle of seeing or watching or seeking for the project or for the product or for the part is different from the first one. So as you can see here, you have these two. You have this is the same product actually, not two product. It's same product, but you look at it from different perspective or from the different angle of view. So if you look at it from the third angle of view, it will look like this one. This side is straight. This side it has some like a circle or semicircle. But if you go to this side and you look it at this one from the angle number one, for example, so it will become like this one. It's straight, and you are going this the circle side is become on the. It's like you look at it from the front on from the back side. But here they call it like first angle projection or second angle projection. So how this part will be represent the front view. So the front view here, the place of the front view with respect to the top view will be different for both sides. If you want to represent this third angle projection into front top right side, it will be different from the first angle projection, which is also will be front top and right side. We will see here. So this is the first angle projection, how it looks like. So you have this, you come from this side, from the angle number one, you want to see, or you want to project or geometric project of this product on this side. Okay, so how to represent this product into the front side here? It become represented by like this one. So this will be the representation, how you are going to see this product from this side or with angle number one. So this is the representation for this front side or for the front side angle. So then the top view will be the same here. You are going to see a rectangular with another rectangular. So this is the part, this is the other part. So this is the place of the top view, and this is the place of the front view. That means the front view is here on the top, and the top view is there based on which plate you are going to use. So this is, you can see here, this is the place of the top view. It will be projected on the horizontal plate or the horizontal plane, and the front view will be placed on the vertical plane, like we said before, A, B, C, D, and so on. So this will be, the top will be on A, and the horizontal, I mean the front will be on B. So as you can see here, if you imagine that it is inside a glass box like we see before, so this will be the front view, for example. This will be the top view here, because this will be projected to this part. And this will be projected to this part of the glass box. For the third projection, the way is different, because we said we are going to see from the angle number 3, which is, we said this is A and B on the top, this is C, and this will be D. This D, as we see before, A, B, A is the horizontal, so this is not A, the A is here. This was the A, this was the B, correct? So this is A, B. Now here we have C and we have D, because we are looking from the angle of 3. So in the case of the 3 angle here, I mean the projection, the third angle projection here. So where is the front view? The front view will be, because you are going to see from this way. So the front view will be, projected on this plane. Okay, then this will be the front view, and the top view here will be from the top. It will be presented on the top view. So the place of this top view become on the top of the glass box, like on the top of the glass box, and the front view become on this front side. But in the previous one, the top view become on the bottom of the glass box, and the front view become on this side, on the side here. So this is the difference between the third and first angle projection. And as we said, this third angle projection only used in US and Canada, and while the first angle projection is used in other countries. Usually, if the drawings represented by the third angle projection, you should extract the view as it is from the third angle projection. That means you are going to represent all the dimension based on this extraction. This is the front view, it will be placed here. This is the top view, will be placed here. This is the right view, for example, will be placed here. But if you use the first, you cannot use third and first. As you can see here in some, in the previous, for example, here you can see, this is, they call it third angle projection. It's already indicated, this is the third angle. So it's not a first angle. If a first angle, the arrangement of the view will be different. So here as more, just to represent it in the form of the glass box. So it can see here for the first and the third angle, it is on the top. Here on the right, on this side for the front view. This is top view. This is right side view. So it will be represented in this way: top, front, right side. But if it is third angle, so the first, the front will be here on this side. This will be the right. This will be the top view. So the top view will be down, front, and right side. So either is first angle or is third angle, it will be represented in the drawing, and also at the same time, it will be arranged or make arrangement for the view in the drawing based on the angle of projection. Is it first or third angle?